Okay, here we are, number 4. It says an object moves along the x-axis with initial position x of 0 equals 2. All that means is at 2 seconds, right? After 0 seconds, it starts at 2. So when it starts, its position is 2. The velocity of the object when t is greater than 0 is given by v of t equals sine of pi over 3t. We are given the velocity function, right? This is a velocity, okay? Question A asks us, what is the velocity of the object at t equals 4? So I just need to find what is v of 4. And that's going to be sine of pi over 3 times 4, which is the same as sine of 4 pi over 3, right? And this is the kind of thing you should know for your unit circle. If you need to, then you spend your 4 minutes, hopefully not, but constructing the entire unit circle. I hope you don't have to do that. What we should kind of be able to recognize is, well, this is pi over 3, this one is 2 pi over 3, and then the one that's down here is 4 pi over 3. And so we want to know sine, which means we want to know the y coordinate of this, which there's only like 2 possibilities, right? I like to think about it as, well, that's the longer side, which, the shorter side is the 1/2, the longer side is the root 3 over 2. So this is root 3 over 2, right? V of 4 is root 3 over 2. And it didn't give us any units, so you don't have to worry about units on that one. That's kind of nice. Part B, at what time, for times between 0 and 2 pi, does the object change directions? All right, so if the object is going to change directions, then it must at some point equal 0. The velocity must be 0, right? If you're going to be moving left and you want to start moving right, you have to stop and then go backwards, right? So I need to figure out at what time does my velocity equal 0. So I'm basically setting my velocity function, which is the one that was given to me, and I'm trying to set it equal to 0. Right? And it's a little bit tricky because, again, this is a unit circle thing, but we're trying to think of sine of what gives me 0. Sine of what gives me 0? Well, I know sine of, I'm going to do this over here, this yellow part. The things that give me 0 are 0 and pi and 2 pi. Right? Those are the values that if I plug in there give me 0. But those are not my t values, right? My t values are, I have to multiply my t values by pi over 3. So I need to say, what is the t value that is going to make this pi over 3 times t give me those yellow values, right? Those values that when I plug into sine, I get 0. So I can set up these little equations like this. The first one's pretty easy to see, that it's going to be t equals 0, right? Multiply both sides by 3, divide by pi, you're just going to keep getting 0. The second one, you multiply both sides by 3 and you divide by pi, right? And the pi's are basically going to cancel out, so you get t equals 3. And then the last one is you multiply both sides by 3, you get 6, and you divide by pi, and you still just have 6, right? Because the pi's cancel out. So t equals 0, 3, and 6. We want to go all the way to 2 pi, which, remember, 2 pi is 2 times 3.14, which is 6.28. So that 6 is going to be the biggest one. The next one would be at like 9, probably, right? So those are our t values where it stops, right? This is where this stops. We should double check that it actually changes directions, right? It needs to go from positive to negative, negative to positive. So let's do that real quick. Let's put 0, 3, 6, and then some other number over here, right? And it doesn't really matter. But I need to make sure it actually changes directions. I don't need to check left of 0 because my whole interval here, as it says up here, is t greater than 0. So I don't care what happens left of 0. I only care about between 0 and 3. So find a number, plug it in between 0 and 3. Right, we're plugging it into sine of pi over 3 times t. What if we plug in, how about 2? Right, this is going to be sine of 2 pi over 3. Positive or negative? That's going up, right? Sine of 2 pi over 3 is this one up here. the sign coordinate there is positive. So this is positive. So it's going to the right. And then let's plug in a number between 3 and 6. How about 4? It's going to be sine of 4 pi over 3. Sine of 4 pi over 3 is this one down here, right? We found that before. And it is also positive. That's not right. This answer up here should have been negative because it's down. Cool, just found a mistake. It's negative because it's in the third quadrant, which the coordinates there are negative, negative. So go back up to A and make sure you fix that. It should have been negative square root of 3 over 2. It's going left. And then between 6 and whatever, I can put whatever there. But let's just keep going with what we've been choosing. I chose 2, I chose 4. Why don't I choose 8? This can be sine of 8 pi over 3. Which 8 pi over 3 is the same if you do it like this is, 1 pi is there, which is, 3 pi over 3. If I go to there, that's 6 pi over 3. And then 7 pi over 3, 8 pi over 3. I'm just back where I started for 2 pi over 3. So it's the same as 2 pi over 3. It's going to be positive again. So how do I answer B? Well, I say, when does it change directions? You'd say, well, it changes direction at t equals 3 and t equals 6. How do I know? Because v of t equals 0 at those times, and the velocity changes signs. Right, the velocity is changing signs for those. All right, let's keep going. Part C, what is the acceleration of the object? Let's do part C over here. What is the acceleration of the object at t equals 4? Remember, I'm given the velocity, and I want to find the acceleration. That's simply the derivative of the velocity. That tells me the acceleration, right? So I have to take the derivative of this. It's going to be cosine pi over 3t times the derivative of the inside is pi over 3. And I want to find the acceleration at 4. So we just plug in 4 here. Right, it's going to be cosine of 4 pi over 3 times pi over 3. We need to figure out what cosine of 4 pi over 3 is. That's down here. It's a cosine. It's negative 1/2 times pi over 3, which is going to give us negative pi over 6. Again, there wasn't any units assigned in this problem, so you don't have to worry about units. And then lastly, consider the following statements. For times between 3 and 4.5, the object is the velocity of the object is decreasing, and for times 3 to 4.5, the speed of the object is increasing. All right, so for times 3 to 4.5, we already did this down here. From 3 to 4.5 is here. Look at this chart, right? From 3 to 4.5, the velocity was decreasing, right? So this statement is true, right? And then statement 2 says for times between 3 and 4.5, the speed is increasing, right? So remember, speed is the absolute value of the velocity. So I need to determine, is that true? In order for that to be true, I need to show that I need to figure out what the acceleration is, right? So we already figured out this acceleration function, which is pi over 3 cosine of pi over 3t. I need to figure out, well, between 3 and 4.5, is the acceleration positive or negative? The easiest way to do this is to set it equal to 0 and then figure out, what are the t values where it's 0 and check around them, because 0 is the only time I can change signs. I solve this, I can divide both sides by pi over 3. It's just going to be 0. And then this is the same idea, right? I'm trying to figure out, well, cosine of what gives me 0, right? Cosine of what gives me 0? And the answers are pi over 2 and 3 pi over 2. Right? Those are the things that if I get those inside the parenthesis, I will get 0. But that's not what I have in there. I have pi over 3t in there. right? And I need to figure out what's the t value that gives me that. So if I solve each of these, this one gives me t equals 3/2. This one gives me t equals 9/2, right? And so that's where the acceleration could possibly change. 3/2 and 9/2. And notice how this 9/2 is 4.5. So I don't need to keep going because I already got that 4.5 there. So let's do this. 0, 3, 6, and then acceleration we're going to do at 3/2 and 4/2. Sorry, not 4/2, 9/2. I'm going to do the acceleration ones in red. Okay, we already know the velocities, right? If I look at the velocities, it was positive there, negative there, and positive after that. The velocity, the acceleration though, if I check between 0 and 3/2, I need to plug in a number up here between 0 and 3/2, like a t value of 1, right? Which would be pi over 3 times cosine of pi over 3. Right, if I'm checking here, I'm doing cosine of pi over 3, which is positive, and then times positive pi over 3 is going to give me positive. If I check after 3/2, it's like 2 cosine of 2 pi over 3 is negative, times, pi over 3 is still negative. All I care about is positive or negative, right? And then from 3, and this is what I really care about, from 3 to 9/2, that's like plugging in 4, right? If I do cosine of 4 pi over 3, that's also going to be negative because it's in the left, it's in the third quadrant. And so what we notice is the velocity and acceleration have the same sign, right? Which means that it is speeding up. So, okay, so we'd say both statements are true, right? When both statements are true, and for statement 1, we can show that, for statement 1, it was the velocity was positive the whole time, but our velocity was negative on the interval from 3 to 4.5. We showed all our work over there for it. And statement 2, we can show that the v of t and a of t had the same sign. Both were negative on the interval 3 to 4.5. So the particle was speeding up because they had the same sign. All right, so we're showing both statements are true. We're giving a little reason why, and we have a ton of justification work up here that shows us how we got that as well. All right, so that is that.